Welcome to the Fetch-Decode-Execute cycle. We've got the CPU inside the arithmetic logic unit, which carries out arithmetic logic operations. The control unit, with which executes instructions, and the registers, memory address register and memory data register. We'll ignore the rest. Hold up. This is boring. From now on, the CPU is a frog. That's better. The CPU frog's function is to request, decode, and execute instructions. The CPU frog controls all input and output. We've got mail storage, representing our memory, which has shelves with addresses with stored mail, mail representing our data. The mail storage and frog office is connected by buses on which signals, ducts, transmit data. On the address bus lane, only memory addresses can be sent from the CPU frog to the storage, while on the data bus lane, data can be transmitted. In this little world, all they know is the fetch-decode-execute cycle, forever and ever. Fetch. First, the CPU frog requests a memory address through the memory address register, the MAR, where the location address for the next data is stored. A signal representing the duck is sent along the memory address bus. The address bus transmits only memory addresses to the primary storage. The duck then finds the mail under the address and brings it along the data bus, because data can only be transmitted on the data bus. Ducks bring mail back to the CPU frog on the memory data register desk. Stage 2. Decoding. The CPU frog takes the mail, decodes it at the control unit desk. The control unit decodes the machine code of the memory into assembly language and processes it. Stage 3. Execution. The frog carries out instruction, perhaps using arithmetic and logic. The ALU, you guessed it, does arithmetic and logic operations. Let's observe them in their natural state.
CPU takes it to the control unit to decode it, and it says, load 1. Whatever could that mean? It sends the duck back to find... I'm writing a little piece of paper, give me a second. And it turns out to find 1. Then it says 1. Go find it, address 1. So the duck reads it, goes back in here, gets address 1, gets it out, brings it in, encodes it, and it means 11, that's what it says. So it puts it at the math text for later. So because the frog has very small memory and therefore can only remember one thing at a time. Right now it's at 11 and she wrote it down on the math desk just so he doesn't forget. Next, it says 11. Alright, so our previous program was at 57. Actually, that's the program counter's name. This is the job of the program counter. There's like a program counter, but we're like ignoring that for this project for some reason. But it's like there. That's the only reason why the program remembers which one's next. So if the previous was 57, that means the next one must be at 58. So the frog writes a little note, writes 58. Now it's 58, so it writes a note to its fellow duck. G thinks what it says. Alright, go back. Come on, we need to do sub 2. Alright, duck. We need 2. Alright, so it says 5. Alright, so what did it say? It said set to sub 2. So this is the contains of 2, so 11. Sub minus 5. This is what the thing wants me to do. Therefore, what next? The frog is quite dumb, therefore it needs very specific instruction on what to do. What next? Alright, we subbed them. We subbed them in my little head, but like I'm not sure if I can keep this answer for long. Therefore, it said, okay, what was the next instruction? 59. 59 is the next instruction. 59. So duck says, Okay, got it, boss. It goes down, gets out 59. Brings it to the MDR. Frog goes, hop, thanks. Store 3. Okay, so we got this result, right? Therefore, we must now store this at number 3. Alright, let me get out a piece of paper so the frog gets magically out a piece of paper. Right, alright, so what was my answer then? My answer was like 11 minus 5, which is like 6. Alright, so put it down. You encode it, I guess. I hope. You better. Yep. Boom. Dog says, alright. The next. But this time, this is a little special occasion because data has to be delivered to the place. Says, yeah, just deliver this to address 3. I think. Boom. To address 3. Duck says, alright. And puts it, overwrites it into whatever there was there. Boom. Now, this one, garbage. All these get mad. The reality is that all of these are actually copied from the data, from the memory. Where were these? I think magically go back to the bird places. There's no tidying up here. Previous one was 59. Therefore, the duck said, hey duck. Hey duck. The next instruction, it has 60. It's at 60. Let me find a slip of paper. 60. The code says end. Phew, and the frog says, thanks goodness. Think frog, that's the end. We're done. Absolutely, hell yeah.